Now we're going to talk about Xavier Koenig's method. So Xavier was inspired by what Rob had done with Iraq, but Xavier's working with WISE and 2-mass bands. He also did a really nice follow-up paper where he had used his method to find young stars, and then he went and got follow-up spectroscopy. And so he's finding about 80% success rate for finding young stars. So again, just like for Rob's approach, you compare colors for each object by making plots. You keep track of where that object falls in those plots. You have a big table with all the accounting set up properly, and then you make an educated guess based on which ones are going to be, you think, the young stars. So here he's got, for WISE, 3.4 minus 4.6 versus 4.6 minus 12. And he's got galaxy models in here. So you've got elliptical galaxies around the stars with that dust down at 0 color. And then you've got red and faint things, and you've got some AGN that are out there too. Now he's going to do 3.4 minus 4.6 versus 4.6 minus 12. And he's working with a set of known stars. So all the big points are a set of known young stars. So he's comparing where those fall to where stars fall, objects fall in from a larger field. And he notices that you've got this big clump of stuff down here. Yes, there are some young stars in there, but the overwhelming majority of the points are galaxies. So he draws the line segments and says, we're just going to drop everything that's in that region. And they keep doing it again and again and again, different combinations of colors, and you notice where the objects fall. So these are well-known class 0s, and they're red in both axes, class 2s, and then stars without dust. Do it again and again. So specifically in the context of IC 417, the 2015 team worked with Xavier to apply his algorithm to the IC 417 region, and he did. He has 2 different pipelines. One that is more reliable, in other words, everything that it detects is likely a real source. But then he's got one that goes fainter. It's likely more complete. It catches everything, but that means that also some fraction of the sources he catches are junk. So because the 2015 NITARP team, just like us, had lots of people working on it, they spent a lot of time on each source so they could weed out the junk. They also used optical IFAST data, so that's RI and H alpha. Where it exists, it doesn't cover our whole region. There's a piece that's missing. They also used UKIDS, which is near infrared like 2-mass, and they used the optical data from the Jose et al. 2008 paper to explore these sources and try to weed out the young stars from the garbage. And they also worked over a slightly larger region than we're working. So, and then moreover, remember that Koenig, around the same time as when the 2015 team was working, was writing a paper on his success rate for finding young stars. So the 2015 NITARP team couldn't do that. So we should look at the Koenig 2015 results to see if we can refine the young star list. So the main takeaway points here from both Rob and Xavier's approaches is that you can do a cut in just one diagram and it works, but cuts in more than one diagram do more to help you separate out the wheat from the chaff. None of the cuts are perfect. They're all going to result in statistical statements like this is more likely than that to be a young star. But you can see that in the diagrams, right? You can see that stars fall in a variety of places and you try to make educated guesses.